Bowden, and as a staff scientist at Big Pharma Incorporated, I have been researching a new drug that brings hope to the issue of antimicrobial resistance. I am presenting my pitch in hopes of receiving funding for Teixobactin research, development, and eventual marketing for use in human populations. What is microbial resistance? So in order to understand the need for Teixobactin today, we need to understand the problem underlying all modern antibiotics, which is antimicrobial resistance. Antimicrobial resistance is when a microorganism can survive and resist exposure to antimicrobial drugs, such as antibiotics. This decreases the efficacy to antibiotic treatments and leads to patient mortality. In order to understand the need for an antibiotic like Teixobactin, one must also understand how antimicrobial resistance happens. In short, when a microorganism is exposed to an antibiotic, the bacteria that have developed resistance are left to proliferate after the course of antibiotics is completed. This allows these new superbacteria to infect more people, rendering antibiotics less and less effective over time. These resistant bacteria can also share the genetic code for their resistance with other bacteria, leading to a further increase in the number of antibiotic-resistant bacteria. Entire classes of antibiotic have become ineffective in treating infections due to antimicrobial resistance, and if we keep moving forward without a solution, eventually most classes of antibiotics will become ineffective. Since the bacterial life cycle is so short, this might come sooner than we think. The next question you might be asking yourself is, why should I care about antimicrobial resistance? Research indicates that antimicrobial resistance is a much bigger threat than many of us realize today. Estimates predict that the number of deaths from antimicrobial bacteria will skyrocket over the next 30 years if something is not done. The current estimates for the year 2050 attribute as many as 10 million deaths per year to antimicrobial resistance. For reference, the estimates for road traffic accidents is at 1.2 million and cancer at 8.2 million. If 10 million people are dying of antimicrobial resistance, this is more than cancer and road traffic accidents combined. The next question you might be wondering is, what on earth does Teixobactin have to do with antimicrobial resistance? First off, Teixobactin is a brand new class of antibiotic. The first new class is covered in over 50 years. Teixobactin works against a broad range of gram-positive bacteria which cause illnesses such as methicillin-resistant Staphylococcus aureus or MRSA, vancomycin-resistant Enterococcus, and Clostridium difficile, C. diff. These are illnesses which threaten human life daily due to the current inability of antibiotics to treat these infections. The unique structure of Teixobactin allows for a two-pronged attack against the bacterial cell wall. This type of attack has been shown in a laboratory setting to not induce antimicrobial resistance over time. Teixobactin has also been shown to work in very low concentrations, making it an ideal candidate for use in humans. Since Teixobactin has not been developed on a commercial scale, there is an opportunity for Big Pharma Incorporated to step in and fill this hole in the market. If we develop a technique for synthesizing Teixobactin, we can patent the specific formulation or synthesis pathway in order to ensure that we are the only company that can market this drug. Since there is a large need for drugs that do not produce antimicrobial resistance, this will surely return a large profit.